So yesterday we mainly discussed about the complex data types, the four built-in data types that were available. We just looked at the very high level, the properties, and then some very trivial examples. So today what we are going to do is we will build upon yesterday's topics, right? And we will look at some examples, and then we will look at scenarios where things like which complex data type would be sufficient, better, would fare better. What if you use any data type where like if probably one particular data type is better, what would happen, right? So we will discuss, this is mostly the practical aspects, and also look into all four data types together, so that we will have the pros and cons of each data type, and it will help us choose an appropriate data type. Because when you write programs that heavily deals with data, like half of the problem is solved, or half of the future issues are rectified when you choose the appropriate data type or a data structure. Even when I say data structure, this is more like how you are going to store a very complex sequence of data. Like it is more like a nested data structure, right? And then the rest of the half is the way you choose to write the logic, right? So storage of data also plays a crucial role in terms of storing, retrieval, performance, memory usage, computation, CPU usage, and everything, right? So any programming language, when you learn, put some extra time to learn the data type, the properties, the limitations, and also like if there are any white papers or any articles that talks about comparing these data types, right? So that always helps. So okay, so I just put together a comparison of these complex data types all in one place. Okay, so if we talk about creating an empty sequence of any of these data types, so list uses the empty square bracket or the list function, tuple uses the empty parenthesis or the okay, so here it's the tuple function, and then dictionary uses a pair of empty braces or the dict function. In order to create a set, we will be using the set function only. Since like we pretty much have only 3 pairs of this brackets and all are used, and also like there will be an ambiguity, right? So if you want to create a sequence and initialize with value in advance, so you use the same bracket, whichever bracket that is applicable, and then put the values comma separated. The exception is if you are creating a tuple with one element, you need to have a trailing blank. So the dictionaries are set up in such a way that every key value will be delimited with a colon, key colon value, and then comma, another key colon, another value, and so on. We use the braces. In order to create a set, you can simply use brace as well. Okay, so in case if there is a confusion, like we use braces for both sets and dictionary, think of it in this way, right? Both has some similar properties, right? Both are unordered, and both has uniqueness. In dictionary, the keys are unique. In set, the elements are unique. Okay, so this is one way you can kind of remember like why we are using the same brace notation for creating a dictionary or a set. In terms of mutability wise, whether you can change a particular variable once the values once the variable is created, except tuple, every other data type is mutable. So that means you would be able to add elements. Okay. In set, in case if you want a tuple like set, right? Like you want to create a set, but you don't want to change it. There is also another additional data type, which is generally probably, I think it is not the original part of the complex data type. Probably it might have gotten added at the later point. There is something called a frozen set. Okay, so if you create a variable equal to frozen set or with some values, then that that set you cannot change it. So in case if you think about creating a unique value of a unique list of values and then you don't want to change it later, there is a additional data type as well. Accessing all these elements in any of these complex data type can be accessed using a for loop, right? So for variable in sequence, and then every iteration the loop runs and you will get one value, right? So in addition to that, the tuple and the list can be accessed through the index value starting from 0 to length of the element, length of the sequence -1, or in the reverse order -1, -2, -3, and so on. Okay. The dictionary, on the other hand, you can use a key to access it. Right? So you give the key and then you access it. Set, on the other hand, doesn't use index or doesn't use a key. It doesn't have that sort of notation because of the basic property of the set. The order doesn't matter. So there are two ways you can access. One is the for loop. Obviously, it will get you a random element from the set, or you can use one of the method to access the element in a set. Okay. And in terms of duplicate values, both tuple and list, you can have duplicates. In dictionary, the keys should be unique. The value can be anything, right? In the set, each element should be unique. What type of values we can have inside these complex data types? So a list can have any data type, right? So element 1 is a number, element 2 is another list, element 3 is a tuple, element 4 is a dictionary. It can be anything, but in general, the application of a list is to have a sequence of homogeneous values, as in the value of same data type, like as a names list. So contain list of strings, which is names. Probably a list called temperature. So you will have temperature recorded over a period of so a period of a day, right? In 24 hours, you might have recorded like every 10 minutes or something like that. Okay, so even though list Python doesn't restrict you, the general application is to use typical set of data of same data type. Tuple, it can have any immutable data type. So like int, a float, a boolean, string, another tuple. Those are all possible values to have in a tuple. In the dictionary, the key is typically a string, right? It's a lookup. So, but you can have numbers also, and the key should be of type which is immutable. So that means you cannot have another dictionary or another list or another set as a key, whereas you can have a string or a number as a key. The value can be anything. And even the set, the individual element should be immutable. We had a discussion about this yesterday, because like once you add an element, if you are able to change it, and if that is making the set losing the uniqueness property, it is a violation, right? So that's the reason set doesn't allow immutable elements. Okay, so this is probably pretty much the properties that you can compare all in one place. So any questions on any of these complex data type that we have discussed so far? So before I get into some more examples.
So I have one quick question.
Okay.
Let's suppose I have a tuple, and in tuple I have one element as a list. Can we do that?
No, right? Because list is mutable again, right?
Okay, but direct element is not gonna change, I believe. So okay, overall.
You can change a list, right? Like for example, like let's say you have index 1 of a tuple is a list, right? For example, it is possible, right? So that element is changeable. So theoretically, you cannot change a tuple, but inside one element, if it is not mutable, then you can change the element, right? And then that is going to violate the principle. You can have another tuple.
Okay.
So that shouldn't be a problem. Okay, so in terms of this immutability and then what type of values you can have, the best way is practice, right? So again, you may not have to remember all those things, but at least what is possible and what is not possible. Simply like you don't even have to write a program, right? So you go to the shell and then you create a tuple, right? So t equal to 1, 2, Alan, right? It works. And then I'm just going to add 1, 3, 5. That's fine as well. And then when I try to add it's hard. Okay, let me take it back. So apparently it does allow changing the element, right? So my bad. Okay, so it's just that you cannot add element, but it does make you. Let me try one more thing. Okay, so apparently you cannot add a new element like append or like insert, but it does allow. It's new to me, right? Like that's what I read. So again, like I mentioned, it's a good way. Like we can actually whenever we read something is not possible, but something is only that's the only thing that is applicable. Then you can try the same thing. For example, I tried this at least, right? So here it is not allowing me to add a list or a dictionary. Okay, so I didn't try all this probabilities, but at least once I tried set it. That's how I remember this. Okay. So okay, so let me see like what I need to update in the comparison. Okay. Thanks for asking though. So even that's a learning for me. Right. Anything else? Okay. So now what we will do is we will quickly take a look at some of the built-in functions and methods available with these complex data types. Okay, so there are several methods in each, so we may not be going through all those things, but just to give a taste, I have documented some of the built-in functions that you can use with the list and some examples along with the methods. Okay, so I have also done the same thing with dictionary, because again, dictionary is probably pretty much one of the most useful data type. But if you want to know more about what methods that are available in a tuple or a set, I would encourage you to use the del function and then get the list of methods available and then do some practice. Okay. So we have, in the first class, we have seen that there are about 70 to 75 built-in functions that are available, right? So they serve a different purpose. For example, like we saw the input, print, help, dir, type. So these are all very basic built-in functions that we saw on the first day. Then we saw the range function. And we also saw that each data type has a function for typecasting or creating a value with, like variable equal to list function, something like that, right? So,
hi, okay, are you able to hear me?
Yeah.
Hi, okay, I have just a doubt. Actually, I used that class object as a value, but can we use the object also as a key? I think I just never tried, but just asking.
The object, I think in a dictionary, if whatever the key is, they have something called hashable, right? Like, so
yeah, hashable.
what internally Python does is it takes the key, it converts into it creates a hash, right? Hash in the sense like sequence of hexadecimal value, and that has to be unique, right? So if the object, whichever object you're trying to use as a key, if that has a hash function implemented, probably you can. But generally objects, I don't think you would be able to use it as a key.
I think values, we can use it as the object.
Yeah, values can be anything. Like you can have a key and then you can have a value, which is another dictionary, another class, another function. Like you can have anything in the value. It's just a key. Like it has. So every time the hash function is invoked, it has to produce the same value, right? Because the key is not stored as it is. So internally, it will be stored in a hexadecimal representation. What happens when you create an object, right? So the object's return value would be some way of representing where the object is stored, right? It is some
kind of pointer kind of thing.
Right. Every time it will change, so that's the reason. Okay, so these are some of the built-in functions I have listed. Okay, so there is a list function obviously in order to create empty list, and then we saw the len function, which will give you the number of elements in a list. And then sorted and reversed, we saw like in order to sort and then get a new list, right? Reverse is just simply change the order of the existing. In both cases, the original value is like untouched, right? And apart from that, there is in order to check the entire element, like list of elements of truth and false, like let's say you have initialized an array list with all values as 0, right? And then during the course of your program, so you are incrementing or you're adding the values at several indexes, and then at the end you want to check whether I initialized like some 100 elements with 0, whether I have touched all these elements and then put a non-zero value, right? So all function will check each and every element, and then it will apply the truth check, right? Yesterday we talked about what is truth and false. So if every element in that list comes as a true, then the all function will return a true. At the same time, any function will take a list, and then if any one of this element is of a type truth, then it will return true as a value. Okay, so this will be like a high level check. Okay, especially like if you have counter variables or something like that, you want to make sure that every element is non-zero or non-empty or something like that, or at least there is one non-zero, non-empty, or whatever. There are not many applications, but since both uses a list as a parameter, I just thought I'll add it over here. And then min, max, and sum. As the name suggests, you send a list, you can get the minimum value, you can get the maximum value, and then you can get some of these values. So this kind of, I have not tried min and max, but sum, if you try to send numbers and strings, or like all strings, there will be issues. Okay, sum expects the list to be of numerical data type in each and every element. And finally, the enumerate, right? So the function, so this is probably one of the underutilized functions, but so this is something that would be really useful. Okay, for example, let's say you have a list, right? And for some reason you need the index, and then you need the value of each element, right? So what we typically do, we say counter equal to 0, and then we iterate the list, and then we get the value, and then we increment the counter, right? So that's what we do a lot of times to, if you want to display or if you want to pass the index value and the individual element. For example, let's say I have a list of like nums equal to list range 100 to 110. Okay. So this is, so if you want to access both the index and the actual value, right? So what we typically do is, there are a couple of ways. One of the ways, counter equal to 0, and then for num in nums, then you say like print counter and then nums, right? And then we say counter plus equal to 0. So sorry. My bad again. So you have the index and then you have the value, right? So what enumerate does is, for in enumerate nums. So you don't need a counter variable, you don't need the increment operation. What enumerate does is, it takes each element and then it will give you a counter. By default, it starts with 0, right? So exactly the same thing as what we did, but this is what we typically do. But the enumerate function is kind of available in other languages as well, but I just don't see that being used a lot, right? Even when we need things like this, we simply tend to go for temporary variables or like counter variables, increment, and so on. Okay, So the enumerate also have other advantages. Okay, for example, you don't want the index, so you want to start with a counter. Maybe you are creating a report, so you want the sequence, to be printed in the, the list of nominees in this training. Probably I have a list of all the names, and then I just want to create a simple Excel with the sequence number and then the, like the employee name, right? So in this case, I don't want this to start with 0. I want to start this with 1. It can be any number. In this case, if I get there are 10 elements, then the counter variable seems to have 1, 2, 3, 4, and so on. Okay. So the application is mostly when you need to pass the get the index along with the actual value, where you don't want to use extra variables, right? So this is a very minimalistic way of coding that sort of situation where we either need a counter or like a serial number or an index along with the element in the list. It doesn't have to be list. You can use other sequences as well. Okay, so I'm just, I just gave you an example. You simply call the built-in function, pass the list, and then it does whatever process you can, right? So built-in methods. So we already know that. So once you have the variable name or a list, so you call the dir function, it will give you the list of built-in methods that are available. Okay, so here I just took it and then I have separated it in terms of the usage, right? So you have a list. If you want to add elements, right, you can actually extend a list. So there are 3 ways you can add element. Okay, one is append. Append is to add one element at the end. Insert is to add one element at any given place. Like you have to provide an index number, and then the element will be added there. So append always at the end. Insert gives you a flexibility to add element wherever you want. Okay. Extend takes another list, unpacks it, and then add the value at the end of the existing list. So let's say I have odd number 1, 2, 1, 3, 5, 7, 9 in one list, right? And then I want to add the even number to it. So I will just say list1 dot extend list2. So both the second list will be unpacked and then individual elements will be added. Okay, so those are the 3 ways you can grow a list. You can, the opposite of growth is shrinking, right? So you have the clear method, simply wipes out every element in the list and then makes the list empty. Pop removes one element at the end. Okay, so it is basically the opposite of append. Remove gives you a flexibility to remove at any given position using an index. Okay, so these are the 3 ways you can remove elements. And then if you want to get some information like the count and the index methods, so you pass a value or element to the count method, and then it will go and look into that list and then see how many times that element existed. Okay, the index will tell you at which position this element that we are looking for existed. Okay, if you remember, these 2 methods are part of the string data type as well, because string is a sequence of characters, right? Even though we call it as a basic data type, so string behaves a lot similar like a list. Like you can use a string of index 0 to get the first element. You can count, use the count method to get the number of vowels or something like that. Then you can look for a particular character using the index method. Okay, but probably you might remember this. If you use the index method and then if you try to look for an element which is not there, so Python will exit with an error. Okay, so you have to make sure that there is appropriate conditions before you do that. And finally, like the sorted and reversed function, list provides a method sort and reverse. Okay, the difference between the built-in functions and the built-in methods are the built-in function takes a list, create a new copy with sorted or reversed output, right? The original list is untouched. The sort and the reverse method, on the other hand, it will manipulate the function itself. The original order is lost. Okay, so if that's what you want, you could use the sort or reverse method. Finally, copy is to create a copy of a list. So you can simply assign list1 equal to list2, or you can say list1 dot copy list2. Okay, so this is something I want you to investigate. Okay, as like, you know, so we have only limited time, we cannot cover every topic. There is a concept called shallow copy and deep copy in you know, like it's a general computer science concept. Okay, so look for shallow copy and deep copy in complex data types and then see how Python implements it. Okay, so that's something I will leave up to you. So there are 11 methods that are available in the list, and if you want to learn or take notes, you could categorize that into subcategory based on the functionality. All you need to do is just simply do a help function on each method, in case if you want to thoroughly learn the properties of a list, and then you can categorize it. Right? I have already done that for the list, a one-line documentation and category, right? For other complex data types, you simply use the dir function with a variable of that type, and then if you look at the very end where you have rid of all the you know, names that starts with underscore, so you will get a list of methods that you can check. For example, tuple, since you can't change anything, since it is like a list, the only two methods that are available in a tuple are count and index, because everything else makes the changes, right? So that is some information. Okay, so here again, so in order to use it, I just have a couple of lists created. So there is one new names list which is empty, and then there is a one names list, so that has 4 names, and so what I am doing is I am appending the value Ashoka to the empty list. Okay, so it doesn't matter, because empty list you append, you insert, you do whatever, there is only one element going to be added. So when I print that, so you will see just Ashoka, right? And then I am doing an insert at position 0, right? So that means what's going to happen is Ashoka will be there initially as a first element. Now the name Rajaraja Chola will become the first element, and then Ashoka will be the second element. The third way, I already have these names, the list of emperors. If I just do an extend on the new names, it is going to add the other 4 emperor names into the new names. Okay, so let me execute this. So initially we just added Ashoka to empty list, so it is there, and then we inserted at the beginning, so it came first, and then Ashoka took the second offset, and then we extended with the existing emperor's name list, and then everything has become like it's like kind of concatenated. Okay. So I would like you guys to try this part. Okay. So what happens if you use an append instead of extend? Okay. So I have given the thing, the snippet you need to run, but you can check on yourself. Okay. So now I will show you how errors are happen. Errors will happen in certain methods. Okay. So I'm just trying to look for a name Napoleon in the list. And if you remember, Napoleon is not in the list. So we only have Charlemagne, Alexander, Genghis Khan, and Hannibal. Okay. So in case if you're wondering who they are, so they are at some point of time they walked on this earth. They are the greatest emperors. Okay. Known for their bravery and whatever it is, right? So Napoleon is not there, so it is giving me a value error because you're trying to use look for a value. It is not there. So whenever you use the index method, always be cautious because it is possible in the runtime whatever you're looking for in the list may not be there, and then your program will come to a stop. So how we can do that? So first of all, there are several ways to do that. One of the ways you use the in function. So you simply look for element in list, right? So it will tell you whether that value is one of the element or not. So if it is true, then you can simply say, hey, Napoleon is at position or offset. So whatever name dot index. Otherwise, you simply say Napoleon didn't make it to the emperor list. So whatever you want to do, like if the index value is not there, maybe you want to add that, or maybe you want to initialize some other value or whatever it is. Okay. The another way to do that is okay. So now what we are going to do is names dot append, right, Napoleon. So here what we are going to do is we are going to check another way, right? Names dot count Napoleon greater than 0. Okay, so you either use the in method or the count, sorry, in keyword or the count. So now so let me just rerun this so that Napoleon won't be there any longer. So if I run this now, so these are the emperors that we had. Right, and then we have added Napoleon. So 0, 1, 2, 3 at 4th position. Okay. So here you have a wide coverage of functions, methods, how they are used, and in case of error, how you can handle. Okay. So if you want to know which methods can produce this kind of error, obviously the way to look into is like one thing is when you try it, it might give you an error. The other way is to look at the help for that particular method. Okay. So any question?
So I have one quick question. So far we learned that there is a 3 way to iterate through the list. One is list itself. Second one is the range function using the list, and then third one is the enumerate. Do we have any other way to iterate through the
So
list?
third one, what did you say?
Enumerate.
In
Enumerate. The last function.
enumerate, yeah. Yes,
So,
first of all, for element in list that you can iterate, right? Range is for the index, right? For then you say range length of the list, then you will get the index, and then using that you can iterate, right? And then enumerate is another thing. I mean, there are other ways. So one of the thing is you can simply say counter equal index equal to 0, and then use a while loop, and then you say that while index less than len of list, and then you can simply access, right? So instead of for loop, you use a while loop, but you generate your own index values. Or okay, so that's another thing probably. So if you don't care about right, your original list, right? Let's say the names list, right? So what you can do is you can just say while names, right? So names is a list that contain like 5 emperor names, right? So print names dot up. Yes, okay. So this is what happens is every time one member will be removed, one element will be removed, right? And then at some point of time, the list is going to be empty. And we saw that the value will be considered false. So if you have the value, if either you have an expression that returns true or false explicitly, or if the value has a value of none, empty string, zeros, or an empty list, or empty set, or empty dictionary, or empty tuple, right? So when you iterate it this way, the original list is destroyed, but at some point the while loop will become false, so you can come out of it. So this might be helpful, like you have a list of events, so you have some sort of asynchronous programming, something gets added, so you don't care about the original thing as long as you get processed, right? So this is another way you can
yeah, this is a great.
So these are all good examples. Probably like okay. One thing is probably this is something that will help us, try out what is applicable or what is possible. And the second thing is based on your existing knowledge, then you will have a personal preference, so you can choose one among it, right?
Yeah.
Okay.
So one more question I have is like we used enumerate, and normally enumerate return you the index with the value. So is there any way that we can just get a value instead of both?
Then you don't need enumerate, right?
Yes. Okay. So enumerate always return index and
Yes,
value.
two values. Like it's a tuple, list of tuples, right? Like every value you put it need not be an index. Think of it like a counter. It starts with 0. You can overwrite. So every element will have a pair of values returned in enumerate.
Okay.
Okay.
All right.
So I mean, enumerate will kind of help you write a very succinct code, right? So that's what it is all about. Maybe if people are not aware of what enumerate is doing, it might be confusing. But since Python provides a way for you to access the indexes also, I mean, there is no harm in using it. Or if somebody is looking into your code, probably they have something to learn from, right? So that's like, so even, there is one drawback when we learn a new language, right? So we tend to write code like the way we used to do in other languages. So if you come back from the C world, so you will try to write a Python program like a C program. So that means the features that Python provides may escape you because you will always think how I will solve that in C, right? Even there are books written about it, like, there is a book called Learn to Code in Pythonic Way, I guess. So Pythonic way of coding is something like you use the features provided by Python rather than how you use the equivalent construct from other language, right? So enumerate is not falling under that category because even Java has the enumerate option. It's just that like there are features that are available, like the else clause along with the for loop, right? So there is a reason for that. So you can use it. Okay.
Yeah.
So let's talk about probably an important but very confusing concept. Okay, so we will just touch at the high level. There is something called list slicing, right? So as the name suggests, slicing is a way you get part of the original whatever, right? So you cut the cake into several slices, everybody gets 1 or 2 pieces, depends on the number of people, right? So unlike the cake slicing, where once everybody is eaten, the original list is gone, the list slicing is a way you can get part of the list. Okay, either like first 10 elements, last 10 elements, every other element, or like every other element, even numbered element, odd numbered element, and so on. Okay. So how that will happen is, you will say new list equal to original list, and you will start with the square bracket, and then you will give 2 or 3 values colon separated. Okay, think of it like the range functions, parameters, right? So you just say 0 and then colon 5, for example, right? So what will happen is it will slice from the first index, and then it will go for 5 elements. That's how you can think of. Or like if you say the second value is 5 and then it stops before 5. So that means if you just say list square bracket 0 colon 5, so you will get the elements from the list of index 0, 1, 2, 3, and 4. Okay, so this is the first confusing thing. Okay, in case if you are looking for, if you are looking to get the elements from index 0 to index 5, then you have to say 0 colon 6. Okay, so the start index included colon end index, the value is not included. Okay, and the second colon, which is optional, you can give a step value. For example, if I say 0 colon 5, so I will get 0, 1, 2, 3, 4, 5, not the index, but the element from index 0, 1, 2, 3, 4, so on, right? If I say 0 colon 5 colon 2, so that's a step value, right? 0, 2, and 4. So I will get only 3 elements from index 2, index 0, index 2, and index 4. Okay. So the list operates a lot like the range. Okay. But it has its own quirks, depends on what you give as the index value and then what you give as the last index value and step and so on. I have several examples, but before that, let me show you another way a list will be useful, right? I have a list called L, then I will have 1, 2, and 3. Right, so this is something that we saw on the first day we talked about a list, right? If I say list L of 0, I will get the value. L of -1, I will get the value as well. If I say a list of an index that is not there, so I am getting an index error, okay? But let's say if I put a colon, right? So it won't error. So that means you are looking for a slice, maybe one element, right? So it is possible. So this is one intuitive way of looking. So I want the element at index 4, okay, but I did not have it. Okay, what am I going to do? Okay, so let's take this. Let me put probably like, okay, so let me put it in such a way that this works actually, right? So it works, right? If I just say this one, it doesn't, because there is no index file. Okay. So assume you are looking into a list, so you want an element in a particular index. Okay, so now there is always a possibility that the list may not be that long. Okay, so then how you will be writing code? So you will say, okay, let's say I'm looking at position 100, right? So you will say length of list. If length of list is at least, greater than or equal to 100, greater than 100, right? Because index 100 means there should be at least 101 element. So if length of list greater than 100, then you will say like get me the list, the value at index 0, or sorry, index 100, right? The other way you can do that is, let's say this is giving an error. So I can simply say um, like element equal to L 5 colon 6, right? So if the value is there, it will return that one element. Okay. Then if I say if element, right, then uh, print. So what we are doing is like we are simply taking the value out, because the output of a slice is always a list. Okay. Else then print 0. So if you remember, there is no fifth element, fifth index. So instead of erroring out, we are getting the value 0. Okay. So now let's put so you get the value 6. So it depends on what you have. So this is probably one of the foolproof way of getting a value from a list based on an index. Just making sure that the list is that long. If you directly try to get an index, if it is not there, then again the Python will port. Okay. So this might be a one side effect, right? So if you try to do a slice and then the index is too small, the slicing returns a empty list. Okay. So now at least you get a taste when I said why it is a confusing topic, right? So if you didn't understand, so that is the purpose, right? So if you really want to master slicing, again, you have to read through the manual and then you have to practice, right? So that is the intention of me showing this. And so in case if you want to practice, okay, maybe I can actually put this in the example, right? So that like you have. So let's let me add it over here. Right, so and then we will add one more, and then I'll say I'll just remove this, and then so we'll have this value, and then so there you go. So you have some examples at the end how you can avoid index errors. Okay. So now let's look at some examples. Okay. So nums. So I have a value between 0 to 8. Okay, a sequence. And then if I want a slice starting from index 2, right? So index 2 is 0, 1, and 2. So 2 to 5, but the index 5 won't be included. So I get a value 2, 3, and 4. Okay, so this is the first thing. Okay, always remember this. First index is included. The value of the element in the last index specified is not included. The second thing, if you don't specify the first index value, 0 will be assumed. If you don't specify the last value, the last index will be assumed. So that means if you want to get from the first element to some nth element, or from the nth element to all the way till the last element, okay, then there is a choice for you. Okay, for example, so what you can do is like, okay, slice 1, slice 2. Okay, so we want to split the numbers by half. Okay, so what I'm going to do is I'm just going to say midpoint equal to int len of nums divided by 2. Okay, so what we are doing is, so we are getting the length of the list and then we divide it by 2, and then we convert that into an int so that we will get the midpoint, but it's a whole number, so we can use it as an index. Nums midpoint, and then nums midpoint print slice 1 print slice 2. Okay, so divide the list equally. Okay, the issue, okay, so there is an extra parenthesis. So if you look at it, so obviously there is an odd numbered list, so obviously we cannot do that equally. So I get the length of the element, length of the list, which is 9. So 9 divided by 4, 9 divided by 2 is 4.5. Converting that into an integer will be 4. So I just say colon 4. So first element, second opposite 0, 1, 2, and 3. So I will get 4 elements. Then I say midpoint colon. So from the 4th index onwards. So I will get this one. Okay. So, so if you want to split a list arbitrarily at a point, so all you need to do is code this statement, right? Original list, colon, midpoint or arbitrary point, and then original list, arbitrary point, colon. So the list is separated. I mean, 2 new lists are created where you have one value before your arbitrary point and then the other value from the arbitrary point till the end. Okay, so this is another application that you could think of using the slicing. And the next thing is you say colon 2. So that means the default value is the first index. The default value for the second parameter is the last index plus 1 and then 2. So that means you will get the odd numbered elements from a list. At the same time, if you say 1 colon 2, you will get the even numbered list. Let's say if I'm giving an index that is not there. So we know that this nums list has only 9 elements. If I give 100 as the end index, again the way we saw in the other example, there are no 100 index, but the slice will give you whatever it can. So that means first index 1, index 3, index 5 and index 7. After that there is nothing, it is not given. If you want to get the value in the reverse order, colon minus 1, right? So 0 to 8 would be the default value, 0, 8, minus 1, right? So that would be 0, minus 1, 0, minus 2, 0, minus 3 and so on. And then as soon as you have the index value lost, then you will stop, right? So if you want to reverse, another way of doing it without using the reverse function is colon minus 1. Okay, so there are a couple of more examples which I'm not going to discuss. So there is the example and there is the output. Okay, so probably this is one of the topic which would be very useful if you understand this completely. Okay, especially if you want to do a slice and dice of your list. Like using a pattern or like nth index or something like that. Okay, again it can be confusing. I totally agree, because when I learned Python, there are times where I actually I skipped this topic after reading few. I just remembered only this part. There is a colon and then like a default values and then step value. Okay, that using the minus, and then the last few examples, frankly speaking, I didn't actually look into that at first. Okay, and then probably when I was revising it later, after 6 months or 7 months after learning Python and then started using it, then I went ahead and learned it. Okay, so it's a useful topic. How much you want to learn? Just the rudimentary things, especially this one. This is a useful one. Probably something like this, it's fine, right? But if you really want to go try out different combination and how things works, why this is empty, for example, and then why this is not, right? And then what is happening here, right? So those kind of things would be very helpful. Okay. So slicing is not just unique to list. You can use it on other complex data type as well, and including strings. So you can do a slice and get substrings. So there is no substring function available in Python. In case if you are wondering, substring function or substring method, it is not available. So if you want to get substrings, so you need to probably use the index count and list slicing if you want to either arbitrarily get or get a substring based on certain values. Okay, so I would say that list, set, all these things are fine, but probably for me my favorite data type is dictionary. Okay, irrespective of any language, a data structure that stores key value pair is something that I found it very convenient. Okay, so dictionary is a data type. It is like the enumerate, right? So like whenever you use tuple or a list, you get only the value when you iterate, right? And the indexes are there, but they are implicit. but you use an enumerate to get the index. Whereas here in dictionary, you provide your own, index for looking up, right? So it is called a key. So there are several of these functions and methods that are available. Okay, so I will let you read this on your own time, but let me quickly take you through how to create dictionaries and then how to access. So we know already how to create an empty dictionary or assign values, right? And how do we iterate? So here is where the for loop significantly differs for dictionary. Okay, whenever you iterate a dictionary, every time the Python returns the one key. It can be any key, right? So it is not in any order. So, but the thing is, every iteration will issue one key, and then using the key, you can use a square bracket notation and get the value. Okay, so here it is. So the way you iterate a dictionary is for variable in dictionary, and then the variable will have the key, and then dictionary square bracket, the key will give you the value that is associated with the key. Okay. And if you want to get only the key, so there is a keys method, and then if you want to get the value, there is a values method. Okay. So where this can be useful is, so if you want to do a reverse lookup, right? For example, let's say I have a lookup table that has the state code and then the state names of the Indian states, right? Like TN for Tamil Nadu and then UP for Uttar Pradesh and so on, right? So the keys are also unique and the values are also unique. So no two state code will have the same name, right? So in a situation where you don't have the state code, but you have the state name that is coming as an input, and then you want to get the corresponding state code, right? So you simply get the key, you simply get the value, and then you iterate and then create a new dictionary where the value become the key and then key will become the value. So using the keys and value functions, value methods, you can access the key. Okay. Here is another thing. These keys can come in any order, okay, but that the benefit is whichever order the keys come in, the corresponding values will come in the same order if you issue a value function. So that means tying together both and then create a new dictionary won't be a problem. The third one is, so let's say you don't want this one, right? So you don't want this way of doing it. You don't want to go and use the square bracket notation. So what actually you want is, so every time you iterate, so you want the okay, so by default it is giving you the keys only. So if I say print, okay, so if you look at here, it has become, like you call a method, but still the value is readily available. You don't have to use the square bracket notation to use it. So this is another way you should be able to iterate the entire functions. Okay. Okay. And probably one of the most important, I would say, two methods is the get and set default. Okay. Let me show you why. So what happens if you access a key which is not there? Okay. So So let me show you. So let's say vehicle dot price. Okay. So let me run this again. So the price is not part of it. Okay. So this original thing, I have only name, model, and company name for a vehicle. So I'm just trying to access the price. Okay. So now, since the price, okay, I can also use this one. So that will be appropriate. So I'm looking for a key called price. It is not available. So what the get method does is it accepts a key and it accepts a default value. So you are looking for a key, but if the key is not there, then you will get the default value. If the key is there, it will return whatever the value is associated. So price is not there, so it returns 4.5 lakhs. Whereas I am looking for another get with the company name. I say like the default value is Tata Motors, but in my hash, in my dictionary, company is already there. So it returns Maruti. Okay. So what happens in the get case is the original dictionary is not disturbed. Okay. Only thing is you're looking for a key. If it is not there, a default value is sent. Okay. You still have name, model, and company only. An equivalent is set default. Okay. So you're looking for a key, right? And then if it is not there, you still want to get the default value. In addition to that, you also want to insert the key with the default value. Okay, so the difference between the get and set default is get will simply give you the default value, leave the original dictionary untouched, whereas the set default will give you the default value and then it will insert it also. So whenever you look into the next time, the key will be there. Okay, so the application of get and set default, we will just look into that shortly. Okay, so now the price is part of it. Okay, and then there is one more method called from keys. Let's say you have a list of names or list of keys, and then you want to initialize them with some value, right? So it is basically creating a dictionary from a list where you have only the keys available. Probably you are going to do some increment and decrement later. You simply call the list, pass the list as a parameter to the from keys, and then you pass the default value. It's simply for each and every element in the list. So it creates that as a key and then adds the default value as a value. To start with, it created a dictionary with list of keys and default value. So this is the some of the demo on the two of those data types. I would request you to go and look into the methods available in tuple and set. So we have already spoken about how sets can be used, especially if you have two lists. So if you want to compare them and then get the common values, or if you want to compare them and get the values that are present in first list but not in the second list, or you want to merge these two lists and then create a unique setup, new list. So all those things set provides methods like union, intersection, difference, and so on. Okay, so it would be difficult for me to cover all four in depth. So I have just chosen arbitrarily the list and dictionary, which has more methods as a matter of fact. So you can look into the set and tuple yourself. Okay, so now I am going to give you a demo, right? So which is probably a simulation, a very basic simulation in terms of data science or data analytics. Okay, so we are not using any of those methods or modules. It's simply what we are going to do is, so there is a, in probability, there is a, I don't know what it is called, theorem or a rule. So like throwing a dice, so the probability of one coming would be 1/6, or the probability of an even number coming would be 1/3, right? So there are rules, like how to get the probability of an event occurring. Okay, there is also a saying, if you run that particular event enough number of times, the probability of a particular element or a particular type occurring would be pretty much equal, right? So let's say if I throw a dice one time, so I get only one number. If I throw 10 times, probably out of the 6 different combination, I might get 3 or 4. If I am lucky, I would get all 6 numbers at least once. So if I throw it 100 times, it's a possibility that like some of the numbers will occur pretty much at the same time. What if I throw the dice 10,000 times or 50,000 times? Then the number of times 1 came, the number of times 2 came, maybe the exact numbers will be different. But if you take a percentage, probably every number would have occurred 16.666 times. Okay, so you throw it enough number of times. Okay, so maybe you are trying to run a simulation, so you have certain possible events. How many times I have to do, call these events or perform these events so that I have an equal probability of everything, like the percentage of, any of those events happening has a equal probability. Okay, so that is a thing, right? I am trying to demo. So now we talked about using appropriate data type, right? So what I am going to do is, it is possible to do that with using both dictionary and list. I don't think a tuple or a set will be qualified. You can try to understand why it is not possible to use a list or tuple to do this, but I will leave that up to you. Okay, the very first thing that we are going to do is, I just have some common code. So I am creating a variable called faces, which will contain the all possible values that can come from a dice, which is 1, 2, 3, 4, 5, and 6. Okay, so here is a list implementation. So I have initialized a list called stats, and then I have a count variable that I will get from the user how many times I want to throw the dice. And then I will convert that into an integer. So I know that how many times I need to. Okay. So now what I am going to do is, okay. So I'm just calling, I'm just iterating the loop, whichever number of times that that user inputted. If they say 1,000, so I want to iterate 1,000 times, and each time I want to get a random face. So how I am doing is, since I really don't need the variable, I need only to put the 1,000. So here the variable value is not important. So I simply use an underscore, which is a placeholder, where the for requires a variable. But since I don't really need that variable, I just put an underscore. And then I use a random choice method, pass the list of possible values, and then randomly get one value. Okay. So again, the usage of choice method is for educational purpose only, because random has the rand int and rand range function methods that we already saw. So you can also say in this place random.randint 1,6 or random.randrange 1,7. Okay, all three will give you a random value of between 1 and 6. Okay, then I simply append the random value to the list. So what will happen is, at the end of this for loop, I will have a list of, let's say if my user input is 1,000 times, 1,000 element is going to be there. Okay. So now we have a list. Now we are getting the output. So we are creating a summary. So we have the possible phases already. So we get the value, how many times a particular value 1 occurs, or 2 occurs, 3 occurs, 4 occurs, 5, and 6 occurs. Okay. And then the percentage is going to be number of times divided by total number of times we throw the dice into 100. And then I simply convert that into format that into 1 decimal space. So let's run this. So this is something that I ran already. So I will simply say like 5,000 times. Okay. So what happens is, so one randomly came 843 times, 860 and 815, 812 and so on. But if you look at it, 16.6 or 16.7 would be ideal value for equal distribution, right? 16.66, 16.66. So like, that's the equal percentage. But when we throw 5,000 times, still we are not there. Okay, at least 2 of them are 16.6. 2 of them are slightly lower, and then 2 occurred way too many times. Okay, so now probably let's run this one more time. I am just going to give 7,500 times. Again, still we have some issues. So maybe I might have to run this several times with several possible values, so that I would be able to find an approximate number of times I need to throw in order to get equal probability for any particular numbers. Okay, so this is one of the implementation I got. So now, okay, so the dictionary, we create a dictionary, we get the count, all these things are same, it's just only the data type is different. And then, so here, this is the important line. Okay, so we still get the phase. And then what we say is lookup phase equal to lookup dot get phase comma 0 plus 1. Okay, so now what will happen here? So there are a couple of things that will happen. The very first time a number occurs. Okay, the very first time you keep on throwing dice. The very first time a number occurs. For example, let's say 6 occurring for the first time. So what we are doing is we are going to get 6 from the lookup dictionary. 6 is not going to be there. And we send 0 instead as a default. So what will happen? It will put 6 as a key, and then it will assign 1, because the key was not there, 0 was returned, and then 1 was added to the 0, and this lookup dictionary will become a value of 1. Let's say 6 occurs again. What will happen is lookup get 6. 6 is already there and the value is 1. So 1 plus 1 will be 2. Then now 6 will be, the key 6 will be updated, incremented by 1. So this is a syntax you will need to use if you want to keep track of how many times certain thing occurs. Okay, so this might be one of the important syntax that you might need, especially if you are processing and then you want to keep track of the number of times certain things occurs. Okay, so this is a typical example. And then the phase part, so this is exactly the same thing. Again here we use the get again, because it's possible, let's say I am just saying only 5 times. Okay, so 5 times if I throw all 6, I won't get. So if I don't use that one, if I directly say times equal to lookup of phase, then it might give an error. Okay, so let me show that as well. Okay, so instead we are saying times equal to equal to lookup phase. Okay, so I'm just going to run this. I will give you, I'll give 10,000 times. Okay, so now it is coming fine. What if I give 5 times? So I'm getting an error saying that key error 2. So that means if you are giving, if there is a possibility that whatever values are possible, if it doesn't occur, then you might end up in having a error. Okay. So if you look between these two examples, so we keep on having every throw in a list, and then we use the all possible values and we use the count function, count method, and then we do some calculation. Here, we simply use the die space as a key, and then every time the value occurs, then you increment. Okay. So both pretty much give you, similar formatted output. Like the values might be different, but depends on how many times you ran. Okay. But now, if you look at the dictionary itself. So this is the dictionary, right? So 5 occurred. So I have 6 elements, 6 key value pairs. Okay, that's good. Now let's see what is the value of a list. Okay. Let me zoom out. See, this is what we have. So I ran with an option of 10,000 times. So the list has this. So think about the same scenario, right? We are not just doing something really big, right? The purpose is that, like, we are trying to find something, but we are not using any of those data science or data analytics modules that are available. So think about a million throw, right? Or a billion throw. Billion times we are going to execute. The dictionary implementation will always have 6 elements. Okay, so there will be some addition, arithmetic operation happens, but with the kind of processes we have, that's not going to be a significant load in the system. Whereas if you have to store a billion elements, right, then it is going to leave a very big memory footprint. Okay, so this is where understanding each data type or how a data structure works and using it appropriately can help you optimize your program. It's not even performance tuning, okay? It is basically a common sense, and then utilizing your knowledge about these data types that will help you to write either memory efficient or processor efficient, CPU efficient, processing efficient code, right? So for example, like if you use a data structure which is called the binary tree, right? While inserting itself, you will have things in sorted order. So if you want to access a particular element, then since it is already there in sorted order, so the number of times you need to look up a particular data structure would be very less compared to an unordered linked list. Okay, so this is something I'm talking about a data structure. I'm not talking about a data type. But the same way it is applicable here in terms of memory. So we have exactly 2 implementation of the same problem. One uses a list and the other one is a dictionary. So the results are pretty much, not pretty much, it's exactly similar. It's not same though, because it's a random event. But if you look at it, the dictionary is very small, the list is very big. So it depends on the number of times you wanted this to get executed. Okay, so this is where selecting an appropriate data type to store your values would help. So it's 11:50, and we have covered all the basic data types, loops, conditions, operators, and so on. So what is left for us is functions, modules, and file IO operations. So that would pretty much cover the basics so that we can move on to write some case studies or look into Python provided modules or like third-party modules that we can utilize. Okay. So tomorrow we will look at functions and modules, probably file IO. So depend in any of those order, probably if it takes around 40-45 minutes for me to do the file IO. So we will do that so that over the weekend, so you can create your own input files and then you can do some manipulation, and then you will also know basic level, basic understanding how to write user-defined functions. So that means when we are done tomorrow, so you will have ample time to practice over the weekend, look into the resources, whatever. So depends on how much time you have. So when you come back on Monday, so Monday and Tuesday, we will look at some advanced topics, which I told you earlier, which was not originally in the plan. So those topics would be like writing Pythonic code. So that means like instead of writing your own logic, so you utilize things like enumerate. So what we will be looking into is concepts like lambda functions, map, reduce, and filter. So those are very catchy words if you know what I mean. The map, reduce, right? So how Python provides you built-in capabilities to do the lambda, map, reduce, filter operations. Okay. So Friday, Monday, and Tuesday, we will be covering most of the topics. There is also the exception handling. We will look at very basic level. And then Thursday, Monday, Tuesday, or Thursday, Friday, and Monday. So I still have not received the pre-survey form filled from everyone. So in case if you have not filled, then please do it. One of the reason is because I just want to know whether we can conduct a session on May 1st, which I believe is a company holiday, right? If most of them agree to it, especially since we are under lockdown, I would love to do that. If not, then we can just conclude our session on Tuesday instead of Monday. Okay. So that's all I have, and I will just